Good morning from Patty's Garage. This morning I'd like to talk a little bit about determining true top dead center on this 1098 Sprite engine. As you can see from the video that I've got a few things set up. I've got a degree wheel, a wire pointer, a stationary pointer. The rocker cover is off, and I'm not sure if we can see it in the video from this vantage point, but there is a piston stop already located in the number one spark plug hole, and this is all in preparation for determining true top dead center. So why is this really even important? In particular, for this 1098, I'm thinking it's worthwhile because it's equipped with a 12G 295 head, which is a larger valve, larger port engine. It's got twin HS2s and Pertronix ignition. So all of these are nice upgrades, so I want to make sure that my timing is optimally set to take advantage of all of these components. One of the first things of concern is that the factory crank pulley timing mark may not be accurate. The timing mark on these old Series A engines is not necessarily a reliable reference. The pulley may have been replaced, timing mark may be incorrectly positioned to begin with. The pulley can have some wear, the timing chain sprockets may have been changed, they may have some wear, and of course all of these manufacturing tolerances can accumulate. So if the mark is actually 3 degrees away from true top dead center, for example, and I set the distributor to 10 degrees before top dead center using that mark, it might be 7 degrees, it might be 13 degrees before top dead center, and that's significant with these little 4-cylinder engines. And secondly, it establishes the real baseline for my ignition timing. I'm planning on doing a lot of advanced curve plotting to optimize ignition timing before doing any further research on the air-fuel ratio meter for my carburetor tuning. So my Pertronix distributor advance is ultimately expressed in crankshaft's degrees relative to true top dead center. So suppose we determine that the pulley mark is 2 degrees retarded from true top dead center. If I set it at 10, I'm actually getting 8. So that may affect starting, idle, throttle response, cruising temperature, fuel economy, full power load. All of those can make the carburetor tuning appear to be the problem when the real problem was ignition timing. So what I'm really looking for is a trustworthy reference for building my advanced curve. And those numbers are really going to be meaningless unless I can absolutely determine what true top dead center is. Once I've established true top dead center, I can accurately determine what the initial timing is, what the mechanical advance is, what the vacuum advance is, and all of that equals my actual timing. And this will give me a solid foundation for optimizing the engine rather than just chasing numbers from a inaccurate pulley marking. And as I mentioned, this can help distinguish between ignition problems and carburetor problems. It's really important to get all of the ignition set up correctly first before you start chasing carburetor issues. You know, if you have poor idle, hesitation, difficulty starting, poor fuel economy, all of those things that you think are carburetor problems may truly be a problem with ignition, timing, advanced curves, and so forth. It's tempting to, you know, I've got AN needles in this, excuse me, right now, and blue springs. I've baselined those carburetors, so it's tempted to start changing some of those if we run into an engine problem. So if the ignition reference is wrong, I can spend a lot of time doing that. So my plan is to establish true top dead center before doing my more serious air fuel ratio readings on the carburetors. So my goal is to get true top dead center and then make a permanent mark on the pulley, and my plan is to do that so that I can get a reading from the top of the engine rather than having to use the factory mark, which requires getting down on the ground and trying to shoot a timing light up against a small little notch on the existing pulley. Once I zero this out, once I find my 0 point, I can then use my rollback timing light to become a really useful tool in measuring accurately what my advance is doing, rather than trying to use that, what I believe to be an inaccurate factory mark. For Wally's 1098 engine, I'm going to be using the positive piston stop method, which is a piston stop that uses the spark plug hole. I'll go into this in more detail when I get actually into doing this, but basically you rotate the engine clockwise and counterclockwise against that engine stop, which is stopping the piston from going, it stops it right at top dead center. And then record the 2 crank positions and establish a midpoint. And at that point, I'll be reading that from down on that degree wheel. And this method eliminates the uncertainty caused by the piston dwelling near top dead center. So as a piston comes up, it's got a little bit of a dwell before it starts going back down. So what we're trying to do is find what I'm calling true top dead center. And with all of that done, we can determine exactly how far Wally's existing pulley mark is from true top dead center, if in fact that's the case. So once I know that number, I can compensate for it, and then I can begin to build my ignition timing advance curve from a known and trustworthy 0 point. So that's kind of the overview of what I'm going to be doing. I'll have we'll kind of videotape some of this along the way to kind of help illustrate what's going on.